Hello student, in previous lecture we have started matrix minima method problems. We have seen I think two or three problems on a matrix minima method. Okay, so in this lecture we will see again one example on a matrix minima method. Okay, so what is the next example? Next example is obtain the initial basic feasible solution of the following transportation problem by using matrix minima method. So this is the transportation table. So we have to find out the initial basic feasible solution of this transportation table. So here origins are O1, O2, O3 with availability 7, 9, 18 and D1, D2, D3, D4 are the destinations with demand 5, 8, 7, 14. If you observe here the summation of AI 7, 9, 18 which equal to 34 and demands 5, 8, 7, 14 which is also equal to 34. So here summation of AI and summation of BI. So demands means BI and availability means AI. So here summation of AI and summation of BI both are equal and that are equal to 34. And hence we can say that the given transportation problem is a balance type problem. Okay, is it clear? Okay. Now what is the method? What is the next steps of this method? So this method is a matrix minima method. Means here we have to find out the smallest element from this given table. From this we have to find out the smallest element from this element. Okay. So if you observe, so here 8 is the smallest element in this table with availability is 18 and demand is 8. Okay, so here we will allocate minimum possible amount 8 from demand at 8. Okay, so take the minimum possible amount at 8, then subtract from demand as well as availability and as well as this total. Okay, so we can get after allocating this 8 to this 8 and subtracting this 8 from demand as well as availability. So here will becomes 0, that means second column will satisfied. So here will remaining only 10. 18 minus 8, that is 10. So similarly we will subtract 8 from this 34. So here will becomes only, that is 26. So here will becomes on will remaining is 26. Okay. So what is the next steps? So next steps we write down the remaining elements. So these are the remaining elements. So these are the remaining elements. So write down the remaining elements from the given transportation problem as well as demand and availabilities. So here 19, 50, 10, 70, 40, 60, 40, 70, 20 are the remaining elements. Okay, demands are 5, 7, 14 and availabilities are 7, 9, 10 which is equal to 26. Okay, that is a balance type problem. Okay, now here we have to find out the smallest element. We have to choose the smallest element which is at a cell, that is 1 1 4, which is cell at a 1 4, that is 10. So 10 is a smallest element from this transportation table. So here we have to allocate minimum possible amount from availabilities as well as demand. So here is a 7 and here is a 14. So therefore we can select the smallest element or smallest number from availabilities. Okay, so 7 we can allocate here at 10, then subtract from availabilities as well as demand. So if you subtract from this row, availabilities here will becomes 0. Okay, that means first row will satisfied and here will remaining only 7. 14 minus 1, that is 7. and also we have to subtract from this, so here will remain only 21. Okay, so what is next steps? We have to write down the remaining elements. So these are the remaining elements, so we have to write down these remaining element in this way: 70, 40, 60, 40, 70, 20. So these are the remaining elements with availabilities 9, 10, and demands are 5, 7, 7. So which is equal to 19. Okay, which is equal to 19. So okay, which is equal to 19. Then what is next? So if you observe from this given table, so here we have to select a smallest element from this remaining elements, that is 20 is the smallest element, and availability here is 10 and demand is 7. So here we have to allocate 7 at 20. So allocating 7 at 20, then subtracting from demand as well as availabilities. So here this column will satisfied, and here will only remaining is 3. Okay, so what is next steps? So write down the another other remaining elements. So that is 70, 40, 40, 70. These are the remaining elements. Okay, so here we have to allocate smallest elements. So here will be remaining only, that is 12. 17 minus 12, 17 minus 17 minus 19 minus 7, that is only will remaining here 12. Okay, so here will remaining only 19. Okay, 19. So what is next steps? So here 70, 40, 40, 70. So these are the remaining elements. So here we have to select a proper element, smallest element. So if you observe, so here 40 and this 40 both are the smallest element. So we have to select in ascending wise first element, that is 40. Okay, so selecting this 40 is a minimum element from the given transportation table, and we have to allocate smallest element from availabilities as well as demand. So if you observe, here is a 9, here is a 7. So here we have to allocate 7 at a 40, then subtract from demand as well as availabilities. So here will only remaining 2. Okay, 9 minus 7, that is 2. So here the second column is satisfied. Okay, so, what is next step? So there are only two elements, 70 and 40. Okay, so from this we can also subtract. So here will only remaining is 5. So here smallest element is a 40 and minimum possible amount here is a 3 and here is a 5. So therefore we can allocate 3 at a 40, then subtract from demand as well as availabilities. So this row will satisfied, and here will remaining only, that is 2. So here will remain only, that is 2, and last element is only 70. So here is the availability is 2, demand is 2. So therefore we can allocate 2 at 70, then we will subtract from availabilities as well as demand. So in this way here the all rim requirement are satisfied. Now we will show all the allocations in the final transportation table to find out the initial basic feasible solution of the given transportation table. Okay, so now we will show all the allocations in this table. So this is your original table, and these 2, 7, 7, 7, 3. So these are 8. So these are the allocations of the elements. Okay, so if you observe, we will show all the allocations step by step in this table. So if you go previous, then you can see first allocation at 8, then second allocation at 10, then third allocation at maybe the this 20, then 40, then this 40, then 70. In this way, we can allocate the elements. Okay, so from this final table, we can find out the initial basic feasible solution. So initial basic feasible solution of this given transportation table is x14 means this 7, so x14 is 7, then x21 that is 2, x21 that is 2, then x23 means that is 7, x23 means 7, then x31 that is 3, then x32 that is this is 8, x31 32 that is 8, then x34 that is 7. So which is called as the initial basic feasible solution of a given transportation table. Okay, now finally we will find out the total cost of the given transportation table, and that total cost is uh, given as 7 into 10 plus 2 into 70, 2 into 70 plus 7 into 40, then plus 3 into 40, 3 into 40 plus 8 into 8, then plus 7 into 20. So if we calculate addition and multiplication, then you will get total cost of this transportation table is 814. So which is the required solution of the given transportation problem of a matrix minima method. Okay, so this is the third example of this matrix minima method. Okay, so I will give you one homework problem to solve you. So you have to solve this problem. So what is the problem? Often the initial basic feasible solution of a given following transportation problem by using matrix minima method. So here you have to apply the same method, that is a matrix minima method, to find out the initial basic feasible solution. So this is the transportation table: origin O1, O2, O3, and supply 483, 489, and demands are 3, 3, 4, 5, 6, and these are the destinations. You can say that destination. Okay, so A, B, C, D, E. So these are 2, 1. This is the table. So this is called as a transportation table. This is called as a transportation table. Okay, so you have to find out the initial basic feasible solution by using matrix minima method. So I will give you answer of this table. So that is initial basic feasible solution is x11 is 1, x14 equal to 3, x21 equal to 2, x25 equal to 6, x32 equal to 3, x33 equal to 4, x34 equal to 2. So this is the answer, and total cost of Z is 78. Okay, so you have to solve this problem as a homework problem. Okay, so here we have completed the second method of our transportation problem, that is matrix minima method. In next lecture we will see third method, that is Hogel's approximation method, that is called as a WAM method, or it is also called as a penalty method. So in next lecture we will see the WAM method, that is Hogel's approximation method.